Hi, today we're going to take a look at area and perimeter on the coordinate plane. So we've got two problems here. One's drastically less work than the other. So let's start there. Even though I got more coordinates, a little easier. Before we do anything, we have to draw a picture. So we're going to take each four of these coordinates, plot them, and see what it gives us. Back 2, up 3, over 3, up 3, over 3, down 1, back 2, down 1. And when we connect these, we end up with a rectangle. So now with this rectangle, we have to find both the area and the perimeter. Starting with the area. Area is going to be everything on the inside of the figure. And where we luck out with this is because we have vertical and horizontal lines describing our figure. So because we have that, we can simply just count over, giving us 5 on the bottom, and we can simply count up 1, 2, 3, 4 on going up and down on the sides. Because we have a rectangle, the bottom and the top are going to be the same, side and side are going to be the same. So we get that. Our area is length times width. When we plug our numbers in, we have a 4 and a 5. It does not matter which order you put those two numbers in, as long as one takes over the other. And area equals 20. When we find perimeter now, perimeter is the distance all the way around the object. It's like putting a fence around it. We're going to add all of those numbers up. 5 plus 5 plus 5, 5 plus 5 plus 4 plus 4. Our perimeter equals 18. It's just that distance on the outside. Okay, so that's with a rectangle. What happens when I have 3 coordinates? 3 coordinates, less coordinates should be less work? Not necessarily. But before we get there, let's plot them. We go back 3, down 3, over 3, up 2, over 3, down 3. Now, like our rectangle over there, we have two sides that are nice and easy to find because we have a vertical and because we have a horizontal line. We can just simply count. So we have 1, 2, 3, 4, 5, 6 on the bottom, 1, 2, 3, 4, 5 on the side. We do have a right triangle here because we have a vertical and a horizontal that meet, which means we could use Pythagorean theorem, a squared plus b squared equals c squared, to find our missing side. But I'm going to go a different route because this is the easy case right here. Sometimes this whole triangle might be slightly tilted, and we might not have a right angle to use a Pythagorean theorem. So what I want to do instead is find the distance formula between these two. And we have these two coordinates here. We're going to label them x, y, 1, 1, 2, and 2. So I want to take those 4 coordinates, or those 4 halves, those 4 numbers, and plug them into our distance formula up here to find what that length is. So we then go distance equals the square root 3 minus negative 3 squared plus 2 minus negative 3 squared. Minus minus turns to a plus, giving us 6 squared plus 5 squared, which is 36, plus 25, which is 61. Square root of 61. And we want to take that one more step further. That square root of 61 is a 7.8. So we just found that this side is 7.8. Now that we have all 3 sides, and again, more often than not, you're going to have to use a distance formula to find the distance from one side to the other. We can then plug everything into our area and perimeter formulas. So area of a triangle equals 1/2 base times height. In this case, 1/2 6 times 5, which is 15. Perimeter is going to be the distance all the way around. So we're going to say 6 plus 5 plus 7.8. Perimeter equals 18.8. And that is using the coordinate plane to find area and perimeter.